All right, welcome back. I have a central impact example problem here where we have two bodies, A and B. They're moving towards each other. VA is 1.5 meters per second to the right. VB is 0.8 meters per second to the left. If you're taking the right, to be the positive direction, then this is going to show up as a negative in our equations. But yeah, they have the exact same mass. That is a simplification by design. You'll see that by the end. And this is going to be a perfectly elastic impact, so the coefficient of restitution is going to be equal to 1. So to get started, let's write the conservation of momentum equation, which is just momentum before is equal to momentum after. So in this case for our system, the momentum before of the whole system is ma times va1 plus mb times vb1. That's the mass of A times basically va1, that's the velocity just before impact. vb1 is the velocity just before impact of object B. And then this is equal to ma va2 plus mb vb2, where we have each mass and its velocity just after impact. All right, so when we look at this, each mass of the object is the same. So ma is equal to mb, which is equal to a generic mass. So what we can do is divide each term by mass, and each of those is going to drop out, and we're left with just the velocities. So we have 1.5 meters per second minus 0.8 meters per second for B is equal to VA2 plus VB2. And we can just simplify the left-hand side, so we have 0.7 meters per second is equal to VA2 plus VB2. All right, so we've got two unknowns here in one equation, so we need a second equation, and that is going to be what we have for the coefficient of restitution. And this is an equation that you should try to memorize if you're studying dynamics. It is E is equal to VB2 minus VA2 over VA1 minus VB1. Ultimately, it is the relative velocity of the separation just after impact divided by the relative velocity of the approach just before impact. And E was given to us. It's perfectly elastic, so that means that E is equal to 1. So we can fill it what we have here. We have 1 is equal to the top, which is unknowns, VB2 minus VA2, over the bottom, which we have, so that's 1.5 meters per second minus negative 0.8 meters per second. Let's extend that out a little bit. So the relative velocity on approach is just 1.5 minus 0.8, that's 2.3, and if we multiply that by both sides, we can basically just bring it up to the side, so we have 2.3 meters per second is equal to VB2 minus VA2. Let's just rearrange this a little bit for VB2. It'll make us easier to substitute in the next step. So let's write VB2 is equal to 2.3 meters per second plus VA2. All right, we're going to just take this VB2 and substitute it into this equation right there. So we get 0.7 meters per second is equal to VA2 plus everything that we just found. So that's 2.3 meters per second plus VA2. So subtract 2.3 from each side, we get negative 1.6 meters per second is equal to 2 VA2. Divide both sides by 2, and we get VA2 is equal to negative 0.8 meters per second. All right, we're going to take that, we're going to substitute that one back into this expression, and we're going to get VB2 is equal to 2.3 meters per second plus negative 0.8 meters per second. And we're going to find that VB2 is equal to positive 1.5 meters per second. All right, and so just notice here we have 1.5 meters per second and negative 0.8. They just switched. So this basically was this velocity was transferred over to this mass, and this velocity was transferred over to that mass. That only happens exactly like this if we have two masses of the exact same amount and the equation is, or the collision is perfectly elastic. So I did that on purpose just to show you it. But if you have a problem with an elastic collision where the masses are slightly different, or basically not exactly the same, then those velocities won't transfer over exactly. So watch out for that. It's not always the case. But yeah, let's just put a box around our answers for VB2 and VA2, the velocities just after impact, and we're good to go. So I'll see you guys in the next video. We'll do some more central impact collision problems.